Okay, we're going to work on solving simple equations. Okay, so this is the equation we have. And it says that this variable plus this constant, if you're unsure what a constant is, this variable and this constant are equal to 13, which is also a constant. Constant is a number without a variable attached to it. Okay. Now, what we're going to do is we're going to go through a balancing method to solve these. And in the first example, I'm going to show you every single step, and then the next two, I'm going to show you shortcuts so that we don't have to write all of this information out. What we want to do in this question is we want to isolate or solve for x, which means I want x by itself. So think of the equal sign as being the middle of an equation. And what we want to do is we want to move the number 4 to the other side, or at least eliminate it out of this side so that only x is left. Okay. Now, in order to do this, we have to use an opposite operation. Okay? So, what would be the opposite of positive 4? Negative 4. Okay? So, an idea is this is plus 4. We need to use the opposite. The idea is we're creating a 0. So, I'll now have x plus 4 minus 4 is equal to 13 minus 4. Think of it like the fraction. Whatever you do to one side, you got to do the other. Just like if we're doing equivalent fractions, whatever you do to the top, you do to the bottom. Is the same with an equation. Now, the reason we've done this is to eliminate our number. Positive 4 and negative 4, what do they actually equal? 0. So really, we have x plus or minus, it doesn't really matter, the value of 0, which is now equal to, and what would 13 minus 4 be? 9. Okay? Now this 0, did I need to include that? No. So now we have x is equal to a value of 9. If you want something a little more concrete, we can try to use these little balancing scales. Okay? I guess these are a bit big. Okay, so a visual to go along with this for kind of using algebra tiles. I've represented x with this variable, or this tile here. This is an unknown amount. We don't know what it is. And we know that this x plus, so together with 4, and these red tiles represent the number 4, are equal to. So right now this is balanced, and I can't actually manipulate the way with one side going up or down, but the idea is that this is balanced right now, and I'm actually going to write a little equal sign there. This is balanced right now, where whatever this unknown number is, plus these 4, is equal to our 13 tiles. Okay. Now, in order to get the x by itself, we need to eliminate. Okay. So with that idea, to eliminate a positive 1, so a cancellation method, I want you guys to realize that positive and negative 1, when combined, will equal what?
0.
Nothing. Positive 1 and a negative 1 combined is nothing. Okay, they cancel each other out. That's the idea here. So in order to cancel out these 4, I'm going to put 4 negatives. 1, 2, 3, 4. So what ends up happening here is if we cancel out one pair at a time, this pair cancels out, this pair cancels out, this pair cancels out, and this pair cancels out. That's great. But whatever I do to one side, I have to do the other. We already talked about that. So because I added 4 or negative 4 to the left of the scale, I need to add another negative 4 to this side of the scale. Okay. Now when we do that, there's obviously going to be some canceling. So we have 1 pair cancels out, 2, 3, 4. So what we now have is only an x on this side. And we have what the x is equal to. Everything else has been canceled out. How many number 1s are there here? There's 3 by 3, which is 9. So we've just discovered that this x value here is equal to the value of 9. Okay, this is our second example. And this one we're going to kind of use a shortcut. Now they call these two different methods, but they are the same thing. So I'm going to show you both methods in this one, and then we're just going to focus on the shortcut in the second one. So assuming we did the same idea, we need to isolate for our x. And I have negative 8 on the one side. Okay? So in order to create a 0, or eliminate negative 8, what would be the opposite operation of this? That's right. So we have x minus 8 plus 8. And remember, whatever we do to the one side, we must do to the other. In this case, the negative and positive 8 create a 0. And 2 and 8 create a x plus 0 is just x. So x is equal to 10. Now, the shortcut method to this, the one that Vincent was talking about, okay, we'll do the exact same question, x minus 8. What he was saying, well, if I know I need to just isolate for my x, the idea is I just want to move my negative 8 to the other side. And when we move something to the other side, and remember when we talk about other side, we mean other side of the equal sign. When we move something to the other side, we use the opposite operation. So what's the opposite of negative 8? We already know this. Positive 8. So we have x is equal to, because we've now moved 8 to the other side, 2 plus 8, or positive 8, and x is equal to 10. Okay? So this method is seemingly faster, but it's doing the exact same thing. If you notice, this is a 0. And we did that. We created a 0 over here and moved positive 8 to the other side. So though they call them one the balance method, the other one called the opposite operation, this is considered balance, this is considered opposite operation, they are identical. The exact same thing. There is no difference. Just some people find one way faster than another. Okay? So on this one, we're going to focus on the shortcut here. Okay? So with our shortcut, again, the whole idea, isolate the variable. We want the variable by itself for solving for x. That means I need to move what number to the other side? Yeah, not just 4, but negative 4. If we were to move negative 4 to the other side, what operation does it become? Positive 4. So I rewrite what's here. I write my x again on the left side is equal to negative 1 plus 4. Great. X is then equal to, we simplify this, just 3. Okay? And that's it. So that's the first half of today's